In this video, we will demonstrate Circuit Design's calculation tool to give us the antenna height required to clear the Fresnel zone. Presumably, a line of sight is enough to establish communication, but in reality, we need to leave some area free. The question is, how much area do we need? When people imagine radio waves travelling, they imagine this. However, in reality, radio waves spread out from the transmitter where they find other paths to the receiver in addition to the direct path. If there is an obstruction, not all of these secondary waves will be able to reach the receiver. So how much area should be left that all the waves reach the receiver? We can define zones based on the path difference between direct and secondary waves. In this case, the path difference that is equal to the integer multiples of half wavelength. 90% of the energy is in the first zone. If an obstruction appears in the first zone, we will get attenuation. So what is the lowest height our antennas can be? The lowest height is where the first zone is just cleared, since this is where the energy is concentrated. We can see the lowest height that just clears the first zone. This is equal to the Fresnel radius at the center. Let us say that the distance between the antennas is 750 meters. We can also enter our working frequency here. The ideal height of both antennas comes out as 11.4 meters. It should also be noted that some blockage is acceptable as long as 60% is cleared, meaning we can lower the height further to 6.8 meters. Let's see what happens if we change the frequency. We can see that lowering the frequency increases its size, bringing it closer to possible obstructions. What happens if we change the distance between the antennas? Increasing the distance also increases the size. We can summarize the behavior of the Fresnel zones as follows. Most of the RF energy is in the direct path. For ideal reception, the first zone, at least 60% of it should be cleared. This sets the minimum height of the antenna. Lower frequency and longer distance increases the Fresnel zone radius. See links below to the article and calculation tool.